Hey everyone, welcome back to the channel Code with AKJ. Today is day 54 of solving GeeksforGeeks problem of the day. Today we are solving an exciting problem called the H index. This is a popular problem for coding interviews. We'll start with a simple brute force solution and then move to a highly efficient optimized solution. So let's dive in. So the problem statement says given an array citations where citations of I represents the number of citations received by the ith paper, and we need to calculate the H index. So here the H index is defined as the largest number H such that the researcher has at least H papers with at least H citations each. So let's look at an example to understand this better. So in the given example 1, there are at least 3 papers with at least 3 citations. So here the H index would be 3. And in the second example, there are at least 2 papers with 2 citations. Hence the H index would be 2. In the same way, the third example, here there are no papers with any of the citations, so H index here would be 0. So let's start with the brute force solution. Here the idea is to check every possible value of H and count how many papers have at least H citations. Understand our brute force approach. Here, since we need to find the highest value of our H index, we'll start with the size of this array, which is H value is 5. We initially start from the size of an array and will decrement till 0. And for these H values, we'll count papers with citations greater than or equal to this particular H value. So here the number of citations are 3, which is less than 5, so we'll skip this. 0 is less than 5, so we'll skip this, and 5 is greater than or equal to 5. We have H value which has at least H citations, so we'll count this particular citation. Coming to the next number of citations, since it is less than H, we'll skip this, and since 0 is less than 5, we'll skip this. So for H value 5, we have 1 citation. We also need to make sure that these number of citations should be greater than or equal to this H value. So since 1 is less than H is not our answer. So we'll decrement our H value from 5 to 4. We'll again check the number of citations which has at least H values. So since 3 is less than 4, we'll skip it. Since 0 is less than 4, we'll skip it. Since 5 is greater than 4, we have a possible answer. And 3 is less than 4, we'll skip it. And 0 is less than 4, we'll skip it. So for index H value 4, we have 1 paper which has at least H citations, which is also less than H. So H is not our possible answer. So we'll decrement our H value to 3. And we'll again check with our number of papers. So since 3 is greater than or equal to 3, we have 1 possible answer. 0 is less than 3, so we'll neglect it. Since 5 is greater than 3, we have possible answer. 3 is greater than 3, we have 1 more possible answer. And 0 is less than 3, we skip it. So for this index value, we have 3 papers which are at least greater than or equal to H citations. So 3 is H index. So let's quickly code this brute force approach and let's submit. So let's start writing our code. We'll take the size of this given vector. We'll start from the size of our array, that is n till it decrements to 0. We'll take our count variable. We'll iterate through our citation values, and if this citation value is greater than equal to our H, we'll increment our count variable. And finally, after we get total number of count of papers, we'll check whether this number of papers are at least equal to our H value or not. So if it satisfies this condition, we'll return our H value, which is our H index. And if not, we'll return 0. Let's compile and run this. So let's submit. As you can see, this approach gives us time limit exceeded because of our time complexity, which is O of n square, and here the space complexity is O of 1. So let's try to optimize this approach. So in our optimal approach, we'll use sorting. So the key observation here would be if the array is sorted in descending order, the H index would be our maximum value of I such that the ith paper has at least I plus 1 citations. So let's understand this with an example. So here's the first example. Here I have sorted this given citations array in descending order, and after sorting this array in descending order, here our task is to find that the ith paper should have at least I plus 1 citations. That is, the given number of papers should be at least the I plus 1 citations. So let's quickly dry run this. So let's write our index values 0, 1, 2, 3, and 4. So for citation 0, we have 5 papers, so the condition holds. So for citation 1, we have 3 papers, so for this also the condition holds. So for index 2, the number of papers are 3, which is greater than or equal to 2. So here also the condition holds. So for citation 3, the number of papers are 0. So for this, the condition breaks. So till the citation 2, our condition gets hold. So the largest index value could be 2 plus 1, that is 3. So in this case, our H index would be 3. So in this way, by sorting our citations array in decreasing order, we will get our maximum index I such that the ith paper should be at least the I plus 1 citations. So let's quickly write this code and let's submit. So let's code our optimal approach where we are using sorting algorithm. So we'll sort this citations array in reverse order, that is in decreasing order, and we'll iterate over our citations array and we'll check if the ith paper, that is citations of I value, has at least I plus 1 citations or not. So this condition satisfied, will return our index I, which would be our largest index. And if not, our by default value would be the size of our array. So let's compile and run this. So let's submit. As you can see, this problem got accepted successfully. Here the time complexity would be O of n log n as we are using sorting algorithm, and space complexity would be O of 1. So let's again try to optimize this approach and not use any sorting function and do this problem in O of n time complexity. So we can solve this H index problem in O of n time using our bucket sort like approach. So here the idea is to count number of papers for each citation value up to n and use this to determine the H index. So let's understand our optimal approach where we use bucket sort and quickly dry run with this example, and later on we'll move on to the code. So approach here would be that we'll create a count array of size n plus 1 where count of I stores the number of papers with exactly I citations. So if a paper has more than n citations, then we'll increment the count of n. And finally, we'll iterate from the highest possible index, which is the size of our citation array, till the index 0, and we'll maintain a cumulative sum of the papers with citations greater than or equal to I. So if this cumulative count is greater than or equal to I, then I is our H index. So let's quickly try and understand this approach. So initially our n value would be 5 and our count array would be initialized with all zeros. So next step here would be to count papers for each citation value. So for citation 3, since it is not greater than equal to 5, we'll directly increment this value in our count array. So our count array changes from 0, 0, 0, 0, 0 to 0, 0, 0, 1, 0 and 0. And we'll again move on to the next citation value, which is citation of 0. So since it is not greater than 5, we'll directly modify our count array, and our array would become 1, 0, 0, 1, 0 and 0. In the same way, our next citation paper, since it is 5 and it is greater than or equal to 5, we'll change our count array to 1, 0, 0, 1, 0, 1. In the same way, we'll calculate the number of papers for these citation value, and our final count array would look like this. 2 0 0 2 0 1. So after finishing our second step, which is counting papers for each citation value, we'll compute our H index. Now to compute our H index, we since need our largest value of our H index, we'll start from the end of the array. We'll calculate the total sum, and this sum should be greater than or equal to Ri to get our highest H index. So we'll take a variable total, which would be initially 0, and we'll take the value of our count array. So count of n would be 1. So since 1 is less than 5, which is index 5, we'll continue with this step. So again we'll move on to the next index, which is index 4. Here the total would be 1, so we'll again skip it since it is less than 4. And we'll again move on to the previous index or the next index. Here the total would be 3, which is greater than or equal to our index 3. So here the condition satisfies, and 3 is our answer for this case, which is our H index. So in this way we'll compute our H index using our count array, which stores the number of papers for each ith citation. So this is our bucket sort approach. So here the time complexity would be O of n and space complexity would be O of n. So let's quickly code this approach and submit. So let's quickly code our optimized solution where we have used bucket sort. So we'll take a vector of count with n plus 1 and initialized with 0. We'll iterate over our citation array and we'll count the number of papers for each citation value. So if this citation value is greater than or equal to n, we'll increment our count variable with n. Else we'll increment the count with that particular citation value. And finally, we'll compute our H index. And since we need larger value of H, we'll start from the last index. We'll also need a total variable which stores the cumulative count of papers. So we'll start with the last index till 0. We'll calculate the sum from the count array. And if this total sum is greater than or equal to I, we have found our largest H index. And finally, after finishing this loop, if we didn't find our ith index, we'll return 0. So let's quickly compile and run this. It's working, so let's submit. As you can see, this problem got accepted successfully. So this approach has a time complexity of O of n as we iterate over the array a few times. And the space complexity is also O of n due to the extra count array. So let's quickly analyze the time complexity and space complexity of the 3 approaches we have discussed so far. So we have started solving this given question using our brute force approach, where the time complexity was O of n square and space complexity was O of 1. And later on we have optimized it using sorting algorithm, where the time complexity was O of n log n and space complexity was O of 1. And finally we have used optimal approach, where we have used bucket sort algorithm, and here's the time complexity was O of n and space complexity was O of n. And that's it, guys. That's how you find the H index efficiently. We started with a simple brute force approach and improved it to an optimized solution. So this problem is a great example of how careful observations can significantly improve performance. So if you found this video helpful, please give it a thumbs up and subscribe for more coding tutorials. And also let me know in the comments which approach you liked better. See you in the next video. Thank you.